A lot darker. Maybe we'll turn that light on. All right. Our next victim here is a A1708 13-inch MacBook Pro. Non-touch bar model. This was, I think, the last one before they went to touch bar. So this is just function keys. And the issue is it doesn't have a backlight. So the first thing we're going to do is plug in a cord here. You can hear the chime. You can hear it boot. I see the Apple logo. I don't know if you can see it. Apple logo. No backlight. So we're going to go ahead and turn this off. Alright, it's off. The first thing I want to check is if it suffers from flex gate. So if the backlight and the LED return flex is broken, which is common to this model as well as the 1706 and the 1707 model. I tend to see it more on laptops that have been used quite a bit. This one seems like it's in really good condition, so I doubt it's the cable, but I've been wrong before, so we're gonna exhaust all possibilities. We'll start with that flex cable. Suction cups do not want to work anymore. Bottom cover of the way. All right. Let's check our cable under the microscope for flex gate. First things first, I need to point it in the correct spot. Let me close the laptop, it will be easier. And it doesn't look like our LCD is broken, or our flex. Usually there'll be a crack right across here. And it's from when you open the screen fully. Right underneath this there's the PCB, and this cable gets pulled up against that PCB and it forms a stress crack right here. But usually if you flex it like this, you can see a distinct line, and it tends to break in this area more. Doesn't look like that's the case though, so we're gonna operate on the premise that it is not the flex cable. We're going to go ahead and unplug the battery and test for short on the backlight. Kind of rule out definitively. Okay. Battery's unplugged. In this area over here, kind of pick it up and show you. This area over here on the logic board, there's a bunch of capacitors. This is actually, I think, the backlight driver, and these are filter caps on backlight output. So we can measure for a short on there. First we'll use diode mode. I'm going to get these screws out of the way. Last thing I don't want to do is scratch this thing while I'm moving it around. We're going to go diode mode. Red probe on ground here. The bottom side is ground. So we're going to get a beep and we're going to get 0 voltage drop. On this side we get 49 milliohms. So let's go to resistance. And what this is going to tell us, 53 ohms. So that's not completely short, but it's low enough. It should be in the kilo ohms. It's low enough that there's a problem. So now that we know that's 53 ohms, let's unplug our LCD. Now we're basically cutting the work in half because we're going to rule out the LCD. Because if the backlight on the LCD is short, then we know we need a new LCD. But if our short did not go away, then we know it's the board. So what is our reading now? 54 ohms. So since our backlight is still shorted, even when the LCD is unplugged, we can pretty much, it's safe to say that our LCD backlight, the LED, the actual LEDs on the, and the circuit that drives it, or runs them on the screen, excuse me, they are not faulty, and therefore our flex is probably okay too. So I think I'm pretty sure we're dealing with a board issue. So what we're going to do is we're going to go ahead and remove the logic board, because I have this weird feeling, and as you can see, this board has never been removed. Everything is still stuck down. I have a weird feeling that the shorted capacitor, because there is a hole on the other side, there's a whole another bank of caps just like this. I have a feeling one of those caps is probably bad. So we're gonna remove our logic board and just have a quick peek and see if our hunch is correct, or if we kind of need to think of something else. Okay, so to remove this logic board, I do need to take off this hinge cover. Because there's a screw down there. Gets kind of confusing because I work on Apple products as well as Windows laptops. So sometimes it gets confusing with how to disassemble. There's our speaker flex, and then underneath our speaker flex is our keyboard flex. Now why Apple decided to overlap those, I'll never know and never understand fully. Okay, battery connector, don't go back down while I'm disassembling the board. That would not be good. I want to be shorting things out and doing extra board repair. This is a very common issue on these computers, that the backlight goes out. I've repaired this. I've done this repair numerous times. Though I don't understand why. I wonder if the backlight circuit has not been designed very well and it gets overdrawn or like overloaded, and those capacitors, you know, cannot filter out all the dirtiness or whatever you want to call it, and they can't handle it. Alright, there's our logic board. USB ports look okay. All right, let's have a peek on the other side of the logic board here. Kind of get all of our metal tools out of the way. Let's go to ScoCam. Let's have a peek on the other side. No obvious cracks. Or did I speak too soon? Kind of zoom in on that guy. Nope. LCD connector looks okay. So what we could do, is, I'm not sure injecting voltage is going to do any good because it's a partial short, not a full short. Yep, still shorted though, so there's got to be something wrong. Yep, we're still at 50 ohms. So nothing has changed. Sorry, I just realized you're in microscope view. I just did resistance and diode mode again on the capacitors to see. So it's not going to make it easy on us with a cracked cap. So we could, oh, don't lose those. The little USB gaskets. But there's a fuse on here. Is there a backlight fuse? Is that our backlight fuse right there? Oh, you can't even see what I'm looking at. It's so washed out you can't even see the P on it. Hang on a second. Aha. There you go. There's a... Let's test that fuse real quick and see if it's got continuity. 0 ohms, so that fuse is good. Don't see any surface cracks in any of those capacitors. So I guess two things we can do. We can either put the board back in the chassis and we can either use our thermal camera or we can dump alcohol on them. But I'm not sure that's going to work. I'm really not sure if a short is gonna register. So I guess leave a comment on what your next move would be. I mean, I could. Oh, you know what? I could just inject. Maybe I'll just inject 1 volt. We'll do some alcohol here. I'll inject some voltage on the backlight circuit, just a little bit. I mean, this line goes up to 50 volts, so we can torture this if we wanted to. I'm not going to. I'm just going to put in a little bit of voltage and current. We'll just kind of start low, work our way up, and see if we can coax the short out without hooking the board back up to the chassis, because in order for the backlight circuit to, for lack of a technical term, engage, you have to have the LCD plugged in. But this rings true for other circuits. If you have a direct short, you can just inject voltage on the circuit without powering the board conventionally. You should be able to get something out of it. We're going to go with 1 amp. Or I'm sorry, 1 volt. Oops, I'm on the wrong channel. Having a multi-channel power supply. So we're at 1 volt, 3 amps. Alright, I'm gonna, without doing any alcohol or anything first, I'm just gonna carefully inject 1 volt in here and see what we get for current and everything. So we're getting nothing really. We're getting 74 milliamps. So that's like nothing. Like nothing at all. Yeah, because it's such a small short. Let's go up to 2 volts. There we go. Now we got 1 watt. So we're definitely generating a little bit of heat, so we can see that, I'm sure. Let me see if I can focus this. Now, if you're not comfortable doing something like this, I don't recommend you do it, because you could easily destroy something without, if you don't know what voltage is supposed to be on this line. These guys are all heating up at the same time, so I wonder if we flip it over. We do it on the other side. Maybe there's something on this side. I'm gonna double check with the schematic though, and see which side is ground and which side is not. I don't want to inject 1 volt just onto ground. That's not gonna make any sense. Let's see. What's the number on this? It's an 875. That's an 875 board. Alright, so PPV out SO LCD backlit is on the bottom. So we're going to do that again. We're going to inject 2 volts at 3 amps. So that's 5 watts. Get my swab ready. I think we have a winner. What do you think? Same guy who always dies. I wonder why that is. So let's have some fun, shall we? We're going to Do that one more time, and then we're going to get the thermal camera out. Yeah, what do you think? Think he's our man? So let's get the thermal camera out. We're going to try this again. We're going to do it two ways here. Alright, so we're gonna fire up the old UTI 260B. I'm going to bring the board a little closer underneath the camera. I need to get a stand. This thing has a nice one of those nice quarter 20 threaded inserts, so on this wall over here I could mount like a temporary mount so I can actually have the camera sitting here. I'm going to turn this overhead off because that's gonna ruin the show. Okay, so I'm going to carefully get my probe in here and get situated. So we're gonna put this right over the board, and ha. I am gonna see if I can drop my overhead camera a little bit. That's the wrong thing to adjust. Let's see if I can get some more slack. Oopsie. I just dumped the overhead. Apologies. Are we back yet? Nope. I'm gonna have to deactivate and reactivate that. Darn it. Alright. My apologies. Alright, we're back. That was not very harmful. Yeah, I can't get you any closer. But if I inject here, you can definitely see that our capacitor buddy is not happy. I know there's a way. This has USB-C ports on it, or an HDMI card. Or I mean HDMI, a micro SD. Did I put one in there? Oh, it actually came with one. That's right. I could record and add it to the video, but I'm not going to do that. You can just take my word for it. You can see that capacitor lighting up like a Christmas tree. Keep torturing him. So he's getting up to 135 degrees. So yeah, he is our culprit for sure. So we can pretty much, from experience, we can deduce that there was a shorted capacitor on the backlight output. And then for fun, because we have one, we can take our thermal camera and torture this guy. You know what? I'm having too much fun. Let's do it one more time. Just because we can. Let's squirt it with alcohol and watch him bubble. So I'm going to come over here on a different cap. Yeah. Alright. I think he's had enough. Let's get him off the board. Okay. That's fun. Isn't science fun, kids? Alright, we got our hot air on. We're going to go ahead and replace him. Not going to worry about doing flux right now. Oh, that alcohol's going to crack. crackle when I spray it with hot air. Okay, I'm gonna turn the noisy smoke extractor on because I don't want to breathe in flux fumes. And we'll extract our little friend off. He's a fighter. Now these capacitors on this line are 2.2 microfarad, 100 volts. Theoretical maximum. I used to pull them off a donor board, but I think I now have a ready supply of them from Mauser.com. Let's dive into the capacitor box. See if we have 2.2 microfarad, 100 volts. Typically when the backlight circuit goes short on these boards, only one capacitor gets shorted. Usually don't get more than one. I've never seen more than one. It's usually the weakest link in the chain, which so happens to just be that one on the end, or there's one on the other side of the board that typically fails. It's like always the same two. It's so weird. I'm not an electrical engineer, so I couldn't tell you why that happens. I just know it does. Alright, I found the capacitors. I need to order more. Not sure why I only ordered as many as I did. Probably expensive. That's probably why people pull them off donor boards. I personally like using new ones. You never know. If the capacitor you pulled off that donor board has been stressed out or not, and can fail. Don't get me wrong, I do use donor boards for sure, but if I can do new, I will. Oh, before we install him, let's check our diode mode to ground now. Bet you it's really high. Yup. What's our resistance? 100K. So yeah, I would say he was the problem. Let's get his replacement. Oh, he's a little different. Where'd you go, buddy? He's got stage fright. Little performance anxiety there, guy. You'll do fine, don't worry. These guys will show you the ropes. Wait for our soldering iron to heat up. Good. Let's clean up our flux mess. We don't want anyone knowing we were here. I just posted a YouTube video, or I'm posting a video about it, that's all. Showing getting flux on this side. Nope, got a couple alcohol stains, but that's about it. Don't need the noisy fan anymore. Don't forget to put the rubber gaskets back on. We'll hook up the Wi-Fi cables just as another way to keep the board from falling out of the chassis when we turn it on. Hello. All right. See what happens. There's the backlight. I don't have the battery hooked up, so it's going to take ages for it to turn on. But you get the picture. No pun intended. I'm going to keep my hand over this because I don't want to ruin this video. I'd like to just be able to upload it without having to edit it by showing somebody's name. There you go. We have backlight. Alright, well, that concludes this repair video. I want to thank you for watching, and we'll see you in the next one. Take care.